Okay, we're going to do just a little bit of chapter 19, which is about electrochemistry, which is my favorite kind of chemistry. We're going to talk about how to balance redox reactions. We just looked at how we identify them and decide who's being oxidized and being reduced. So this is just a little bit of review from a few minutes ago, right? We can use oil rig. We can also say that oxidation is an increase in oxidation state. Reduction is a decrease or a reduction in the oxidation state. So here's a balanced equation. We've got the calcium being oxidized, the hydrogens being reduced. So the mass has to balance. We're familiar with that, but the charge also has to balance. So in this equation, none of the species have charges, but there's a total of 0 on the left and 0 on the right. Sometimes you'll, especially with net ionic equations, you'll see ions in there, and we have to get the charges to balance. Sometimes that's simple, and sometimes with redox reactions, it's not at all simple. So the method we use is called the half reaction method. We're going to take the chemical equation and separate it into the oxidation part and the reduction part. We call those half reactions. This is a review of oxidation states. Not going to go over that because we just learned that. I don't think we need to review that too much. But just remind you of this. So pho is yummy noodles, right? And if we just get rid of the end of its letter there, it's F. Pho 765, fluorine, hydrogen, oxygen, group 7, group 6, group 5. Okay, so this is the new stuff. Half reaction method. So first of all, assigning oxidation states to all the atoms, identifying what's being oxidized and reduced. Sometimes it's actually quite obvious because it's a simple reaction. There's only two things. Then we separate the overall reaction into two half reactions. We've got one for oxidation, we've got one for reduction. We're going to balance each half reaction separately. First, we're going to balance by mass. So balance everything but the hydrogen and the oxygen. Then balance oxygen, and we're going to balance oxygen by adding water where needed, because all of these are aqueous reactions. Sometimes the water participates in the reaction. And after we balance the oxygen, we'll balance the hydrogen, and we'll do that by adding hydrogen ions. Then we balance with respect to charge by adding electrons. And we decide that by looking at the overall charge on each side of the arrow, and we add electrons as necessary to cause the charges to be equal. Then we're going to make the number of electrons in each half reaction equal. And then we're going to add them together. The electrons will cancel out, and sometimes some of the other stuff will cancel out as well. And then we should always check at the end. Okay, so now I've read you the rules for the board game. Now we'll practice and play, and it'll hopefully begin to make sense. So balance the redox reaction. So we look at this reaction, and before we learned about oxidation states and charges and things, we say, well, there's one aluminum and one aluminum, there's one copper, what's the problem? But in the reactants, we have overall a positive 2 charge, and in the products, we have overall a positive 3 charge. What happened to that electron? Where did it go? This is not balanced. So I wrote the short version of the rules over here so we can refer to this. So assigning oxidation states. I'm going to do this fairly quickly. So you can always go back on YouTube and watch it again. So here I have an element. So that's going to be 0. And copper 2 ion is going to have a +2 oxidation state. The aluminum ion is going to be +3 because that's its charge. And then I have elemental copper, so that's 0. So I can see that the aluminum is going up in oxidation state, so that's being oxidized. The copper is going down, that's being reduced. So I'm going to make two separate equations. I'm going to take the oxidation part and make it into an equation, and I'm going to take the reduction part and make it into an equation. So here I've got aluminum being oxidized. It's going from Al to Al3+. So that's my oxidation. We've got Al going to Al3+. And then the reduction is the Cu2+ going to Cu. Everybody okay with that? Now I'm going to balance with respect to mass. Do I have the same number of atoms of each element on each side? One aluminum, one copper, one copper. That's all cool. There isn't any oxygen, there isn't any hydrogen, so I don't need to do these next two parts. Now I'm going to balance each half reaction with respect to charge, because here I've got 0 charge on the left and +3 charge on the right. So to balance that, I'm going to put electrons into the equation. Electrons have negative charges, so if I add 3 electrons here, I've got 3 negative charges with the 3 positive charges. That'll add up to 0, which is the same as the other side. That makes sense? Here I've got the positive charge on the left and 0 charge on the right. So I need to add the electrons on the other side. I need 2 electrons here. So -2 and +2 adds up to 0, and that's 0. Everybody okay with that? So now step number 5, make the number of electrons equal. So I have 3 electrons here and 2 electrons there. I need to multiply each of these by something to get the same number. So we're looking for a least common multiple here. So that would be 6, right? I can multiply this by 3, I can multiply the 3 by 2 to get 6, and I multiply this one by 3, and I can get 6. So this is a balanced equation. When I multiply it, I multiply all the coefficients. So I'm going to take that oxidation and I'm going to multiply by 2. So I'm going to be 2 aluminums and 2 aluminums and 6 electrons. I'm going to multiply the other one by 3. So I've multiplied this by 3 and I get 6. Oh, I didn't leave much space, did I? And this needs to be a 3, and that needs to be a 3. Everybody okay with that? Now I'm going to add these 2 equations together. We do this in math. You can do it in chemistry too. So I'm going to end up with 6 electrons on one side and 6 electrons on the other side. Those are like the spectator ions. So I can just cross those off. The electrons should always cancel out, because that's why we made the number of electrons on each equal. And notice this is an oxidation. Oxidation is loss of electrons. There's the electrons that are lost. Reduction is gain. Here are the reductions that are being gained by the copper. So I canceled out the electrons. I'm going to copy down the other stuff. So I've got 2 aluminum solid plus 3 copper 2. That's aqueous. And I've got 2 aluminum 3+ ions and 3 copper ions. Then we should verify 2 and 2 aluminums, 3 and 3 coppers. Total charge on the right side, 2 times 3, positive 6. Total charge on the left side, 3 times 2, positive 6. There's my balanced redox equation. Any questions? Let's play that game again. Here's H plus Cr going to hydrogen gas plus Cr2 plus. Well, The hydrogen here is +1, because that's what its charge is, and the chromium is 0, it's an element. On the right, we've got 0 for the element and +2 for this chromium. So the hydrogen is being reduced, the chromium is being oxidized. I'm going to separate this into two half reactions. I'm going to try to space it out better this time. So I've got H plus going to H2. That's one of them. And I've got Cr going to Cr2 plus. Are you okay with that? Balance with respect to mass. Other elements. Well, that one doesn't have any other elements. Here, one chromium. Okay, that one's all done. There's no oxygens. Balance the hydrogens. So here I've got two hydrogens. This is H plus, which is what I'm supposed to be adding. So I need two of those, right? Two H pluses. Now let's balance with respect to charge. So I've got +2 charge over here and 0 over there. How many electrons am I going to need? 2. Do I put them on the reactant side or the product side? Reactant side. I put them where the positive charge is. So I'll put 2 electrons over here with the +2, so this adds up to 0. And down here in the bottom, I've got 0 and +2. So how many electrons do I need? 2. I'm going to put them over here, right? Because +2 and -2 add up to 0. You'll end up with electrons on the left side for one half reaction and electrons on the right side for the other. Any questions yet? So we need to make the number of electrons in each half reaction equal. They're already equal. What do you know? So now we're going to add these two reactions together. So I've got 2 electrons and 2 electrons. Those cancel out. And I'll copy down what's left. 2H plus aqueous plus Cr solid, forming H2 gas plus Cr2 plus aqueous. Double check that the atoms are balanced and the charges are balanced, and they are. Any questions? Let's do one without the little notes on the side. So identifying the oxidation states is nice. It's not actually absolutely necessary. Most of these are going to be pretty simple. Here I have 2 reactants and 2 products. There's only one way to put these together, or actually take them apart, that would make any sense. This Fe2 plus is obviously becoming Fe3 plus. So that's going to be one of the half reactions. Fe2 plus, excuse me, to Fe3 plus. And we can balance this just fine without actually acknowledging whether that's being oxidized or reduced. The MnO4 minus and the Mn2 plus have to be the other ones. It's permanganate ion and manganese 2 ion. First, we balance with respect to mass. So the first one iron and 1 iron, is already balanced. The second one is going to be a little more complicated. Here's manganese and manganese, so that's all good. But there's oxygen here, and there's no oxygen over here. What the heck? And if you were handed this and tried to balance it without doing half reactions, you probably give yourself a headache because there's oxygen here and there's no oxygen on the other side. So we balance the oxygen by adding water. That's entirely fine to do because this is in aqueous solution. There's water everywhere. So if I have 4 oxygens here, that tells me I need 2 water molecules on the right side. No. How many do I need? I need 4. I need 4 oxygens. This is oxygen I'm looking at, not hydrogen. So 4 oxygens. So 4 oxygens and 4 oxygens. But now I introduced hydrogen, and that wasn't there before. The rules say balance the hydrogen by adding hydrogen ions. We're balancing equations in acidic solution. We're going to add hydrogen ions. So now I've got 8 hydrogens over here. So to balance that, I'm going to put 8 hydrogen ions on the reactant side. And now I have mass balance. All the atoms are balanced. Now we need to balance for the charges. So how do I fix the top half reaction? I don't need to get to 0 on both sides. I just need them to be the same. And I do it by adding electrons. 1 electron over here. So if I add 1 electron here, now I've got a total of +2 here and +2 there. That's balanced. The bottom one's a little more complicated. Here I've got 8 positive charges and 1 negative. So that's a total of +7. And over here I have a total of +2. So I need this to come down 5. So I'm going to add 5 electrons. 5 electrons and this negative here, so that's a total of 6 negative charges and 8 positive charges. So a total of +2 on that side, +2 on this side. Okay? What was the next step? Make the electrons equal. Right? This one has 5 electrons, this only has 1 electron. It doesn't matter what the number is, they just need to be the same. So I can multiply this top reaction by 5, so I can have 5 electrons. So 5 iron, 2, making 5 iron, 3 plus 5 electrons. Now we're ready to add them together. So 5 electrons on one side, 5 on the other, those cancel out. And then I'm going to copy down the rest of it. The order doesn't matter. So 5 Fe2 plus 8 hydrogen ions plus the permanganate ion and over here 5 Fe3 plus ions and manganese 2 ion and water. If you check the charges, you've got 15 plus 2, 17 over here. 10 plus 8, 18 minus 1, 17. Good luck coming up with that, balancing this by inspection. Any questions? I kind of feel like I'm dropping a bomb on you guys. Sorry. You want another example in acidic solution? Okay. Yeah. Yes, please. Okay. Personally, I like to just skip the whole assigning oxidation states. Let's just separate this into 2 parts. So the copper and the copper, those have to go together, right? So I've got copper solid and copper 2+ aqueous. And then this NO3 and the NO2 seem to go together. Okay, first, well, actually it's the second step, but what do we do next? We're going to balance the mass, the atoms, okay? So the top one is good to go. The bottom one, nitrogen, one on each side, but there's 3 oxygens here and only 2 oxygens there. What do we add to balance oxygen? Water. So I'm going to add 1 water molecule to the right side here. So I've got 3 oxygens and 3 oxygens. What do we add to balance the hydrogen ions? H+. So here I have 2 hydrogens. That means on the other side, I'm going to have 2 hydrogen ions. Okay? So now all the elements are balanced. What do we balance next? The charge, right? So the top one, I've got a total of 0 on the left, +2 on the right. All I can do is add negative charges, add electrons. So I'm going to add 2 electrons. So they're going to be 0 on both sides. Sometimes it's 0, sometimes it's some other number. It just needs to be the same on each side. Down here, I've got no charges on the right. I have +2 and -1. Together, that's a +1. So I just need 1 electron on the bottom. What do we do next? The electrons need to be the same, right? This one has 2 electrons, so when this happens, 2 electrons are given off. I need to fix this so that it can take 2 electrons. So I multiply all the coefficients by the same number. That way it's still balanced. So I'm going to multiply by 2. So then I'm going to have 2 electrons. I'm going to have 4 hydrogen ions, 2 nitrate ions, 2 nitrogen dioxide molecules, and 2 water molecules. Okay? The electrons are equal. Now we can add them together. So I have 2 electrons on each side. I cross those out. And start writing down what's left. So I've got copper, 4 hydrogens, 2 nitrate ions, and then I've got Cu2+, and 2 NO2, and 2 H2O. Then we should verify that. Any questions? Mm-hmm. Why didn't I multiply the top by anything? I had 2 electrons here. I want to get the smallest number of electrons. And I had 1 down here. So if I just multiply this one, I could get them the same. I'd rather not multiply if I don't have to. Yeah?
The top one, you added 2 electrons on the right side.
Yes.
So when doing like our homework, when we add to the right side, the bottom one, are we going to add to the left side?
It doesn't matter. It depends on whether you're adding to the right or to the left, depends on whether you have the reduction or the oxidation on top. And since this is just you doing your work, it doesn't matter if you put the oxidation reaction on top or the oxidation reaction on the bottom. Here, this is loss of electrons, so this is oxidation and this is the reduction reaction. Yeah, I'm adding them over here because that's the only way I can get the charges to be equal. Because I can't do anything with positives, I can only add negatives. It's not confusing. Any questions? Okay, that was balancing in an acidic solution. No, yeah. What if we have a basic solution? Okay, there's just one extra step. Do everything else the same. But like this one, we ended up here and we had hydrogen ions. Well, that's an acidic solution. If it's a basic solution, we're going to have hydroxide ions. So all we're going to do is we're going to add hydroxide ions to both sides. Hydrogen ions plus hydroxide ions make what? Water. So we'll add some hydroxide ions to get rid of the hydrogen ions. And then we'll be good. So that's the one additional step. So let's do this example. We've got iodide and permanganate ion making iodine and manganese dioxide. Or manganese 2 oxide, sorry. So again, we're going to take this into 2 pieces. So the iodine things are going to be together. And the manganese containing things are going to be together. I didn't give myself enough room. It's helpful if you write these so that the arrows line up. Makes it less confusing later. So I've split them into 2 half reactions. There's only one way you can do this one, because if you've got I- going to MnO2, good luck balancing that, right? Okay, so we balance with respect to mass. I have 1 iodine here, and I have 2 iodines there. So I'll put a 2 in front of the I-. And down here, I'm going to balance the manganese first. I have 1 and 1, so that's okay. Then I'm going to add water molecules to balance oxygen. So I have 2 oxygens here and 4 there. So I have to add 2 water molecules over here. 4 oxygens, 2 plus 2 is 4 oxygens. Then I add hydrogen ions to balance the hydrogens. So we want to do that instead of adding hydroxide, because adding hydroxide messes with both of them. So we add hydrogen ions. So I've got 4 hydrogens here, so I'm going to put 4 hydrogen ions on the other side. So I've got mass balance. Now I'm going to balance the electrons, the charges. So in the top half reaction, I've got -2 charge on this side and a 0 over here. So I need to add 2 electrons to this. Right? So I'm adding 2 electrons. So now I've got -2 on both sides. Down here I've got +4 and -1. That's a total of +3. And on the other side it's 0. How do I get a +3 to be a 0? I add 3 electrons. So I've got a total of 0 on each side there. So what's next? Electrons? So I've got 2 here and 3 there. The lowest we can get those to agree is a 6. So I need to make the top have 6 electrons. So I multiply by 3. So this becomes a 6, and this would be a 3, and this would be a 6. You have to write all of this out very clearly because it's so easy to make one little mistake. Part of me wanted to write a 6 there, but that would be wrong. The bottom one we're multiplying by 2. So that makes this a 6, multiplying by 2, that's 8, multiplied by 2, multiplied by 2, multiplied by 2. In the past, I've taken care of the hydrogen ions before I add them together, but I just realized It would be easier to do that at the very end, so that's what we're going to do. So we're just going to continue on as if this were in acidic solution. So I've got 6 electrons and 6 electrons. Those are always going to cross out because we set it up that way. So now I'm going to write down what I've got left here. So I've got 6 I minus, and I've got 8 hydrogen ions, and I've got 2 permanganate ions. And then over here I have 3 iodine molecules and 2 manganese 2 things and 4 water molecules. Let's go through that and double check. Okay, that we would be done if this was acidic solution. But this is basic solution. So we're going to add hydroxide ions, the same number to each side, so we're not going to mess up the charge balance or the mass balance. We're going to find the hydrogen ions in here, and there's 8 of them. So I want to add 8 hydroxides. So I'm going to add in 8 hydroxide ions to this side and 8 hydroxide ions to that side. So 8 hydroxides with 8 hydrogen ions. This turns into 8 water molecules, right? Everybody with me? Magic or something. So we have a balanced equation here, but what's funky about it is I have 8 water molecules on this side and I have 4 water molecules on that side. It's kind of not right. So if I subtracted 4 water molecules from this side, get rid of those 4, and got rid of 4 from this side, instead of 8 now I've got 4, because 8 minus 4. Subtracted 4 water molecules from each side. Now we're done. Yeah. Yes. Starting where? Adding the hydroxide, the orange stuff?
Yes.
Okay. So we had our balanced equation, but we had hydrogen ions here, and this is supposed to be in basic solution. We need to get rid of the hydrogen ions. So we do that by adding an equal number of hydroxide ions. Because if we add 8 hydroxide ions to the 8 hydrogen ions, those will combine and form 8 water molecules. Over here, I also added 8 hydroxide ions so that things are still balanced. Then we observe that we have water present on both sides of the reaction. So we would like it to only be on the one side. I had 4 water molecules here and 8 over there. So if I subtract 4 water molecules from each side, now I don't have water over here. I just have it over here. And so that's how I got the 4H2O. Does that help? Anybody else?